Hello all. Okay, so this will be my first lecture about syzygy.ca, Jupyter Notebook, and R. And as I mentioned in the introduction to the course, this course is going to involve a little bit of computer work, not super intense computer work, but you'll still have to do a lot because I think it is a very important component in data science. So the first thing that I want to do in that context is to provide you with a little introduction to this syzygy program, platform, let's say, Jupyter Notebook and R. I will say more about Python perhaps in a later lecture, but I will remind you that in terms of the assignments that you will have to do in coding, you will need to return them in R, actually in Jupyter Notebook using R. So this is what the purpose of this lecture is. Before I go any further, I am not going to show you my ugly face today because I think it's best if we focus on the content rather than have me in the corner. But I hope I am intelligible. So let's start. So the first thing is this platform syzygy.ca. I'm not entirely sure this is how you are supposed to say it, but that's how I am going to say it. So the address is simple, it's syzygy.ca, and you have access to this as University of Manitoba students. So let me right away go full screen. This way we can focus on the website itself. So when you go to syzygy.ca, you will get here. Do not worry about that thing in the middle. I'm not talking about the eye of Jupyter. I'm talking about the send message interface. Where you want to go is up on that upper right corner where it says launch. And here you want to select UManitoba. What this will do is it will take you, let me just check that it's still recording. It is. It will take you to this page, and you see that now the address on the left has changed to umanitoba.syzygy.ca. And so here you click that little house, which takes you to your University of Manitoba login page. So my address is this one, as you know. You will have to input your myumanitoba.ca email, then your password and sign in, and hopefully it will work. Okay, yes. So this is where you will land, although your directory list here will most likely be empty. Now, let me say a few things about this environment here. So this is called the Jupyter Hub. It's the main landing page for using Jupyter. Okay. As I said, there's a list of files that will appear progressively as you are making them. The other tabs, well, they will indicate what notebooks are running. Let me shut down the notebooks and for now. Clusters we're not going to look at least not yet. So the main thing is files. When you're here, you have several actions that you can perform. You can upload a file, or you can create notebooks or text files folder, which will be useful to sort your work, and a terminal, which is just a terminal window that will allow you some basic Unix commands. So let's go to the folder for our course. And again, you will find here a list of files. The files with the extension IPyNB are Jupyter notebooks, notebook files. The other ones are various files that I'll go over later. If you want to create a file from scratch, you would create either a Python 3 notebook or an R notebook, typically. Let me just show you. So I am going to put on UMLearn the notebooks with which we work and what you would want to do in this case. And I've taken a sample one, which is the same as the one we're going to work on today. But just to show you, you click upload. I've put it in my downloads. This is, so remember, IPyNB is a notebook. So here I just open this and you see it's here, and now I go upload, and now this test upload file is here. I can probably delete it because it's exactly the same as the one above. And if you want to delete, well, you can see you have a variety of options, but here I'm just going to delete it. It was to show you the uploading capacity. Yes, I am sure I want to delete. Okay, so let's open the notebook that I want to go over. And this is this notebook here. So what has happened when I clicked is, because remember I'm full screen, I have created a new tab and the file is now open in the new tab. So before I go any further, I want to point out that it's very important that you keep this tab open for one simple reason, which I ran into recently. So you can see here it says autosave. And if you're working, you can, on a notebook, you can actually save explicitly, but sometimes if, for instance, you were to leave this window open without doing anything for quite a while, you would see a sign appearing here next to this not trusted sign that would say something like autosave impossible or not authorized. I don't remember exactly what it says, but essentially the notebook is still running. You can still run code, but you cannot save, which is very annoying. So if that were to happen, it means you're not authenticated anymore. And so what you do is you go back to your Jupyter Hub tab and you just refresh. Refreshing, if you're not authenticated anymore, will send you back to the Manitoba authentication page where you enter your email and password, re-authenticates you, and when you go back to your notebook, it will be authenticated again and you will be able to save again. So remember to always do that, and if you're stuck and cannot save, remember to do that. Now, this is what is called a notebook. So first of all, it's an R notebook. Okay, you can see it here by this symbol on the upper right. This means it's in R. If I were to create, let me just show you for the principle. If I were to create a Python 3 notebook, I would create a new notebook, and here you see that it now says that it's a Python 3 kernel, and this is the symbol for Python. So this means my notebook is one where Python code will run instead of R code. Okay, so let's kill this one. We don't need it. Let's go back to our notebook. So let me explain the general context of a notebook. So a notebook, whether it's running Python or R, is a concatenate, well, I mean, it's putting together text editing capacity and code running capacity. So there's two types of cells, two main types of cells that are of concern to us here. So a cell like this one, or this one, is in Markdown, and you can see it here in this drop down. So Markdown is a language, a text typesetting language. Okay, it's a very low level, very easy to learn text typesetting language. I will go over this quickly. The other type of cells that you can have are code cells. So if this is an R notebook, it will be R code. If it's a Python notebook, it will be Python code. I don't believe it's possible to mix both simply. I mean, it's probably feasible, but in a way you have to choose one way or the other. Okay, let's go back to Markdown for a second. So Markdown is, as I said, it's a typesetting language. It allows you to create text that looks relatively good using very, very simple commands. So here, the most important command, well, not the most, but one of the important commands would be this one. So a hash sign followed by a space and text is a top level section. If I go below, I can put two hash signs and this would be a subsection. Or I could put three hash signs and that would be a subsection, let's say. Now, one remark to show you how this works, both for Markdown cells, but also for R cells or code cells. If you want to evaluate a cell, you just need to press Control Enter or hit Run here. Okay. So let me show you what happens here. So you see I did 3 hash. So this is a single hash, so it's a top level section. This is a subsection, it's slightly smaller. This is a subsection, it's slightly smaller, and so on. So let me remove those two. If I want things to appear as typeset like this, like computer code, for instance, then I just use this backward slanted sign. If I want to use a link, if I want to typeset a link, I put the link text between square brackets and the link location between parentheses. So for example, look at this one. I say this will show here and here will be linked to this address. And this, let's check this right away. And you can see here, and this in passing is one place that you can look at for more information about Markdown. And you can see there's a lot of documentation. There's some editors. So one thing that is very nice with Markdown is that you can actually find quite a lot of editors, both under Linux, Mac, or Windows, which allow you to, on one side of the screen, type your Markdown code, and in real time on the right of the screen shows you the appearance that this would have either as HTML, as PDF, etc. Okay, so Markdown is a very useful way of doing things. Let me very briefly show you another thing that is quite cool with Markdown. Let me for instance, let me make a table. So to make a table in Markdown, it's quite simple. You need vertical bars. Then you would put a title. Then another vertical bar, content. and another vertical bar. And then to say that this is a table, all I need to do is something like this, like a vertical bar, 3 dashes, a vertical bar, 3 dashes. Okay, so this says 2 columns, and then I would have then, I don't know, A8, B, it doesn't really matter but if you put spaces or not. B would be 7, and that's it. And if I render this, you see this nice little table right away appearing here. And for instance, if I wanted to say that this column was centered, then I would simply say use semicolons, not semicolons, columns here and there. If I have one on each side, if I have one on the left, it's left aligned, one on the right, right aligned, and one on each side is aligned to the center. And oops, okay, I did something wrong. Never mind. But you see, I mean, so look up the help for Markdown. It's simple, but it's really useful because it looks quite nice once it's rendered, despite being so easy to do. Another thing, let me just show you if I want to make an ordered list, an unordered list, bullet list. I can just do something like this, A, B, and then if I want to make a sub list, I just throw in a tab and say, well, now actually let's make a numbered list. So this would be blah, blah. And just in passing, I can just use 1 again. Normally, if it's a proper Markdown, blue, blue, then when I render this, you can see first, this is an unordered list with bullets, and this is an ordered list with numbers, and it's automatically detected that I was numbering, and so the second is 2, despite the fact that here I used 1. Okay, so I mean, take a look at the help. You will see it's a great language for this. So this is it for, actually, let me see if I can make this bigger. I wonder if it's possible for me to make this any larger. I don't know how to do this. Let me see, Control plus. Oh, yes, okay. I don't know if this is going to, yes, okay, this looks much nicer. And it will be easier for you to see, probably. I mean, it's not as clear, but it is bigger. Okay, let me see if I can continue. Control plus. Okay, this is much nicer. Okay, so I said 2 types of cells, Markdown cells and code cells. The way you decide is either like this, or you can, there are shortcuts, which I think you find here. No, this is not, I don't remember where the shortcuts are. Never mind. Well, I mean, yes, they appear here. For instance, if I want to insert a cell, you see I can use A if I want it above, or B below. And then, for instance, if I want to make a code cell, I use a Y. If I want to make a Markdown cell, I use an M. Okay, so this is it for this. So this is the idea behind the notebook. So now this here is our first line of R code, and in R the hash, contrary to Markdown where it represents a section, in R hash is a comment. So anything that follows a hash is ignored by the language. So if I evaluate this, I get nothing because there is nothing. Now, the example that I'm going to go over now is something we will use once we start working on least squares, which will come the next lecture, perhaps actually at the end of this lecture, depending how long this description is. So what I'm going to want to do in this particular lecture or set of lectures is I'm going to show you how to perform least squares approaches. And to do that, well, we need some data. And I'm going to use the fact of getting the data from the web and putting it in a form that will be useful to us to explain some basic notions about R. Okay. Now, I thought about what type of data I could use, and I thought, well, the simplest would be to look at the Canadian census data. This is very official data. It's been collected for many years now, and so it's quite a useful resource to consider. Now, what I'm going to do is I'm going to show you how to grab such data to use it for whatever purpose you have. And so I'm looking for census data. And so what I did is I searched, I used this search combination in Google. I searched for Canada Historical Census Data, CSV. This is this last little piece, the CSV, is very important in many aspects in data science. CSV is comma-separated values, and it's one of the simplest ways to describe a table of numbers, okay, or not necessarily only numbers, I mean a table of data. So if you have Mac or Windows, CSV would typically be opened by Excel. I'm under Linux, so it will be LibreOffice or some other thing, but essentially it's something that Excel or any similar program knows how to read, but it's much simpler than what it is, I mean, other than Excel spreadsheets, because what it consists in is a list of values or variables separated by commas, with each line typically having the same number of commas. Okay, and you can find CSVs for everything. So doing my little search, I found this website. It's a Statistics Canada website. As you will see often, this is an archived website, but what's going to be of interest to us is this table, A214, population of Canada by province, census dates from 1851 to 1976. And if we click on this, you see we get a CSV, and you can see that it's actually proposing to me to open it with LibreOffice Calc, which is the equivalent of Excel. Okay, but that's not what I'm going to do. What I'm going to do is I'm going to, you see this address here, I'm going to use this address, copy link, to get the data directly into our notebook. So let's go back to the notebook. Actually, it's interesting. This address is simpler here. Let me paste this one. Let's see if it works. So in R, there's a function called read.csv, which reads a CSV file. The good thing is that it reads a local CSV file on your drive, if that's where it is, but it can also read it directly from the web this way. So what I'm doing is this, and then I am going to, because if I, so I'll comment things out just to point out, I mean, to show what happens. So if I do this, you see nothing happening, because what's happened, so I've evaluated the cell, by the way, I've done Control Enter here. I should show it like this, but So I don't see anything because the variable was just entered in memory. It wasn't displayed. So if I want to display, I can, for instance, just repeat the name of a variable without saying anything, and I will get the variable shown here in the notebook. Okay, another remark before I go any further, I'll just point out that in R, say hardcore R coders, typically they don't use equal to attribute a value, they use this sign. So it's a less and minus, okay, put together side to side. Those two things mean exactly the same thing. Let me copy this here. They have exactly the same effect. I actually like it, but I always forget to do it because all the languages I've used before didn't use this assignation sign. This, if you're used to algorithmics, this is how we formally denote attribution. So this is actually quite nice, but both work. Here I'm going to load the data twice, doesn't really matter. And so here is my table. So now if you look at this table, there's problems with the table. So first of all, let me point out, so what you get in both instances is what is called a data frame, and that's the basic table format for R. It's very powerful. It allows you to do a lot of things. But that's the default in which data is read. And this is a table with 31 rows and 23 columns. Okay, so I can go to the right there and go all the way to the 23rd column. And I'll point out that the way it's showing here in Jupyter Hub, which is actually quite nice, it is also showing you what type of data format is used in each column. So you can see here, this is integers, these are characters, integers, characters, etc. Okay, but if you look at it, these are the column names. They are not very nice. And furthermore, I mean, if you look down in the table, you realize that the one that we probably want for the column names is this one. Okay, the year and the population of Canada. We're only interested in the population of Canada, not of the provinces. Okay, and note also that what they've done is this very cute thing that I hadn't seen before. They want to write Prince Edward Island in full, so they write it over 3 rows. This is not very nice, but that's the way the data comes. So we're going to wrangle this data a little bit just to make it suit our needs. So what we are going to do is we're going to ignore these 2 first rows in the file to start with this one. This is very easy to do. There's an R command for doing this in the read CSV file, and let me update the address. In the read CSV file, you can add this extra, and the arguments are separated by commas. You can add this little comment here to say that you want to skip the first 2 lines or rows, okay, in the file. So if I do this, well, now it looks better. I've got my year, Canada, Newfound, and Prince, and whatever, but I don't really care about all of those. What I care about is year and Canada, because if you look down, this is the population, this is the year of the census, and this is the population of Canada on that year. So this is looking good already, except that now I have a little problem, because these rows, I don't care about them. Those first 4 rows, I don't really care. Well, I mean, it's not I don't really care. I don't want to keep them. And also, well, I don't, as I said before, I don't really care about all of those. I just want the population of Canada. So I'm just going to keep the year and the population of Canada. So how do I do this? And this is very common to most languages that have good capacity with matrices, what I'm going to say is I'm going to take the sub matrix or sub table that starts at row 5 and goes all the way to, so this is the dimension of the table, so the table being data old, dim of data old. Let me, just in passing, I will add from time to time as we're going on, I will show you how things run, but I need to open a cell just to do that. So if I look at dim of data old, this is those numbers that you saw here. Where was this? Okay, yes, 29 by 23, okay. And so if I want the first component of the result, which is the number of rows, I just say dim of data old 1, that's the number of rows, and that's the number of columns. Okay, so what this is saying, what this is saying here, this is doing an enumeration of all the integers from 5 to 23. 29, sorry, there's 29 rows. So you see these are the numbers, and the same way 2, 3, is just the enumeration of all the numbers from integers from 2 to 3 included. Okay, so what this is saying here is to delete a cell, you just go to the left and then you press DD, D twice. So what this is saying here is that data old, the new data frame, is actually the old data frame, but in which I am going to keep only rows 5 to 29 and columns 2 and 3. Okay, so now I've got 25 rows and 2 columns. The columns are year and Canada. And there's a bunch of rows. What you can see here is there's still a few problems. So here, for instance, there's nothing. This one is empty. I'd like to get rid of it. These ones here, they've got some remarks. I also would like to get rid of them. I'm only interested in the data itself. There's another problem here, is that I have commas in my numbers, and this is not numbers, okay? So what do I need to do? I need to get rid of all the rows that have, and if you notice this column, even for these comments, this column is empty. So all the columns I want to get, all the rows I want to get rid of, they have nothing in that Canada column. So how do I do this? Well, these are this is the sequence of things that I'm going to do. And once again, I'm going to decompose to show you what's happening. So first of all, let me point out that you can access a column either by its number. So here I have 2 columns, and so Canada as a column here is column number 2. So I can say data old of comma. So if there's nothing here, it means all the rows for column 2. Okay. Or I can also, when it's a data table and that the column has a name, the name here is Canada, I can use a $sign and then start typing Canada. So I could type it in full, but I can also, once I have enough letters, I can hit tab and it's completed. This shows me exactly the same thing, okay? So to select those rows with missing Canada content, well, I have to remember that this is a chain of character variable. So if it has nothing, it means it's got the empty chain of character. Okay, it's not a 0, it's not empty, it's got the empty chain, which you can see here, by the way. So how do I find those? Well, I can look at each entry in the column Canada and say, well, which entry is not equal to the empty chain. The empty chain is just two quotes, one after the other without any space. And this gives me the truth value of, for each successive entry in that column, of this statement. So this statement here is data old Canada is not equal to the empty chain. And so the first one is true. And indeed, if I go to this first row, this is not the empty chain. The second one will be false because it is indeed equal to the empty chain. So it's different from the so this is different from the empty chain. This one is equal to the empty chain, therefore this statement is false. Okay, so this is a vector of truth values. But if I want to know which indices are true, I can just then say which. And this is going to tell me which of the entries in this vector of truth values are true. And so you see, I've got 1, 3, 4, 5. These are the entries for which it's true. So when I do this, then I am selecting from data old the rows, because this is the first index, otherwise it would be the columns, okay? So I'm selecting the rows that are here. And all the columns, I want to keep all the information. So let's do this. So when we evaluate this, we're going to make data old. And let me plot the result, show the result. So you see, I now have only the rows that have non-zero entries, non-empty entries here. The second thing I want to do is I want to get rid of those commas. Okay, I want to make them numbers. So this is done with this function here, gsub. Gsub means replace as long as you find occurrences of comma, replace it with nothing. Okay, so let's see this. And every time, remember, you have to reassign the result to where you want it to be. So data of Canada is what I get when I do this. So now you can see I have removed the commas. We're in good shape. The next thing I want to do is I want to make this change the order, because typically I want the dates to be increasing, not decreasing. To do this, I'm going to use this little function, which is quite useful. So this is interesting because it's easy to make mistakes when you're doing this. So this is a table with 2 columns, but I want to sort on the first column. So if I sort, let me just show you first. If I sort as a function called sort, and if I say sort data old year, then what I'm going to see is a properly sorted list of vectors, of dates. But the problem here is if I sort like this, it's not going to sort the other components, okay? It's not going to sort the population correspondingly. It's just going to say that the years are well ordered, okay? So what we do instead of that, and it's a very common thing to do, we use this function order. So order, what it does is it shows you, so let me show you first what data old looks like. So data old is this. So what order does is it tells you what index of row, in the vector, what index in the vector you should take to get the proper order. Okay, so this is a vector that has 16 rows, a table that has 16 rows, and order says if you want to order this year column, then you should look first at the 16th entry, then the 15th, then the 14th, etc. Okay, there's other ways to do it. There's something that's called revert, and that would be able to revert the entire table. But I think this is very important to see. Okay, so once we have this order, we can then simply reorder the entries in the matrix by looking at the rows in the original order data, but looking at them in the order that we get through this vector. So when we do this, we are looking at the original matrix in which we are looking at rows in this way, which means that in final, what we have is the properly ordered list of vectors, list of rows. And now the last two problems are those that I said here, the fact that I have characters here. So if, for example, let me show you what would happen if I said, but suppose I want to multiply by 2 the population in 1851. So that would be what data old Canada of 1. But if I multiply this by 2, I have a problem because this is a character chain, not a number. So I can't multiply this by 2. And so this is the last thing we do here, is we make both the years and the population numbers. Okay, and once we do this, let me delete this. Once we do this, we're here. So we have the year and Canada are indeed doubles. So doubles are numbers. They're ordered in the proper way. There's this thing here on the side, which is the order, the number of the rows at the beginning. And this is a little weird. It's not really important at all, but it's just annoying. So let's fix it. And to fix it, I simply need to say that the names of the rows, so row names of the matrix, are equal to, well, 1 to the dimension. And once I do that, my rows are numbered consecutively. Okay, so now let's plot. So this is okay. So let's plot it. And plot is very simple. Let me show you. So you are plotting, this is the x-axis, this is the y-axis. Everything is separated by commas. Type B means that I'm going to use both lines and points. Okay, if I used L, I would have only lines. If I used P, I would have only points. B means both. LWD is line width. I'm making it a little bigger than usual. And xlab and ylab are the label of the x-axis and y-axis. So let's run this. And you can see your population. So automatically it's chosen some axis labels. So these are not very nice. I'll show you probably in a later lecture how to make them a bit better. But it's still okay. Okay, let me just show you what I was saying before. If I use L instead, then I have just the lines. If I use P instead, then I have just the points. I tend to prefer having both. Just note that anyway, those lines are just interpolation. Okay, they're just lines that are made to go between the 2 points. In this case, I don't have more resolution, but I think it's easier to read like this. Okay, so the only problem here is that we're only going to 1976. So we're going to do a bit more, and we'd like to go at least into 2010s or something. So if you, I did another search, I found this table here, which is again archived, but now we have population and dwelling counts in Canada for the years 656 to 2011. So we'll be missing 2016 and 2021, 2016, the results of the census have all, of course, been released. 2021, that's not the case, but never mind. So I want to get this data, it's here. So I have a link here that I can use read CSV on, which is what I'm doing here. It's quite a big file, so obviously it's got more information than the one we downloaded earlier. You can see it's less columns, it's only 5 columns, but it has almost 10,000 lines. And if you read, it's always good to look at what the data looks like. So we don't have the same problem as before. Here, the first row seems to be good. But we've got, okay, the population of Canada in thousands. That's looking good with the years. So it's in thousands, so we'll need to multiply by 1,000. That's okay. But we've also got population change. We don't really care about this. And then we have private dwellings. Then we have the population levels for the provinces and territories, and then the groups of provinces, etc. So that's a lot of information we don't really care about. All we want to continue our plot in the future are these 2 columns here, years and total, for Canada. So let's select this. And this is something you'll do a lot when you're playing with data. You start with a big table which has a lot more information than you want, and you do stuff until you select only the data that you want to keep. So what do I want? I want Canada for the geography name. Okay, I want the top level unit, and the characteristic I want is the population in thousands. So one way to do this, there's several, and I will show you several ways throughout the course, but one way is, let's do it naively. And once again, I'm going to open a window to show you how things work. So the things I want, they have in common the characteristic to have a geography name Canada, but there's going to be way more rows that have this geography name, and the population in thousands. But again, there's going to be way more. So one thing that I can do is look for the indices as we've done before. So we want the indices. If I, oops, what am I doing? Bookmarks, no. If I look for the indices of the rows where the geography name is Canada, I get this quite extensive list. And likewise, if I look at the rows where characteristic is population in thousands, then I get this list. But what I want is the intersection of both lists. Okay, so I can just write down this first set of indices, write down this second set of indices, and the things I'm interested in will be in the intersection of both of these sets. Okay, and this is what I'm doing here. So I'm setting a first set of indices to be index of Canada. So this is which rows have Canada as their geography name. Index of characteristic, which rows have population in thousands as their characteristic. And then the rows I want to keep are those that are the intersection of those 2 sets. Okay, let's see. And indeed, we get rows 1 to 12. So again, now we have a set of indices we want to keep, and we simply say that our data set now consists in the former data set in which we just keep those rows and all columns. Okay, we're not done yet. Okay, so what's happening? So in the previous one, I had a problem because I had commas, but here these are doubles. Okay, this I want, so I'm going to concatenate put end to end 2 tables, 2 data frames. And so if I'm going to do that, I need the data types in the 2 to be the same, and I need the sizes to be the same. So years verse needs to be a double, well, a number, and the names should be the same also. So what I'm going to do is the following. So first of all, I am going to, in the old data set, I'm just going to say the columns are year and population. I prefer that, okay, rather than, what was it, year and Canada. In the new data set, I'm just going to keep those two columns here, years and total, and I'm going to give them the same name as in the old data set. This way I'm good. I am going to make the years numbers in this table. I am going to keep only, because remember that we go up to 1976 in the other data frame, so these things I don't need. All I need are those here. So what I'm going to do is I am going to keep only those rows where the year is over 76. And finally, I need to multiply my population in the new table by 1,000 because these are in thousands. Okay, and to finish this, so I have two data frames which are of compatible sizes, compatible entry types, and now what I can do is I can put them together with this R bind, which is row bind, so it concatenates one table below another. There's another that's called C bind that would concatenate one table to the right of the other one. And yes, and here, and then I will show data. Okay, so there it is. We have census data from 1851. So by the way, notice that it's every 10 years until 1951, and then it becomes every 5 years. So we're going from 1851 to 2011. I can delete this. And we're ready. Let's plot this, same as before, except that I've had to change, of course, to the proper names in the table. And that's a much more complete table, graph. Okay, so I'm going to 2011. So I'm missing 2016 and 2021, as I said. It's actually interesting because this way we will see how good we are doing when we are doing least squares. One last thing. So when you've spent this time, I mean, of course, I'm explaining a lot here, and you would do this much faster once you're used to it. But when you've spent that much time putting together a data set, it's worth saving it. So here I've put two commands which can be used to save a data set. The first one writes a CSV file. So that's the same type of file we've been reading from the internet, but here it's going to save it locally to your Jupyter account, well, to your syzygy account directory. Or another type of save is using what's called an RDS file. I'm actually not sure what that stands for, but it's a compressed native R data format. So if you have very large data sets, for instance, because it will often happen that you have variables that are 1 gig in size or even bigger. If you have something like this, it's really worth it considering saving and loading as RDS, because this is compressed and it's loading much, much faster than if you had a big table with a lot of just numbers that are human readable, so to speak. So a CSV file. So for instance, some of the work I do, I get a table that's about 20 million lines every year. If you want to read a CSV file with 50 or 60 columns and 20 million lines, it takes a long time. Whereas once you've saved it as RDS, it goes much, much faster. And once you evaluate this, you can go back to your Jupyter hub and check that it has created Canada census.csv and Canada census.rds. And let me show you, RDS you won't be able to look into, but the census will give you this tab, comma separated value file where the first row is the name of the columns and then the numbers are there. And just in passing, let me show you something else. I have used row names equals false because if you don't do that, so let me comment out this. So I don't know if I can refresh this. No, I probably can't. So let me reopen it. If I open it like this, you will see that what it has done is it has printed the row number, and those row numbers don't often make any sense. You see here, these are the new rows that I've added, and their numbers are 61, 71, etc. I mean, it doesn't make much sense. So it's much better most of the time to actually save using the option without row names, in which case you'll get this file. Okay. What else did I want to say about this? Let me see. Yes. So, for instance, when you want to submit, I think there's a way for you to submit to me directly when you're thinking about an assignment, but otherwise for assignments, unless I find another way to do it, a very easy way to get your code is to go to the file here and download as. And if you download as IPyNB, then you will get the entire notebook as the one I uploaded at the beginning. And note that you can also get it as PDF, for example. That would be quite nice. It could be quite nice. I'm not entirely sure what's happening. Open with document viewer. Yes. So you can see that here it's generated. This is looking super ugly because the table is looking ugly. It should look better later. Yes, exactly. But you see, you can generate a nice PDF. Which doesn't look too bad, actually. You can generate HTML files. Reload. Oops, what's happened? Hope it hasn't broken anything. No, looks good. So that's it for this. Maybe I will take a few minutes just to try something else, just to show you. Let me download as R. And this is just to show you what's called RStudio. I don't know exactly how it's going to come out. So okay, so here what it's done is it's downloaded only the R part of the code. So I could run all of this and get the same results as we've got. Let me see, source. Yeah, it's made the graphs. Normally I should have two, indeed. So you see, and this is just in passing. So of course, it's good to use Jupyter Notebook, and as I said, I will expect you to return your work, your computer work as Jupyter Notebooks. But for those of you who are more serious about programming in R, you might also want to look into this. And so in terms of using R, I'll just point out, so the best programming environment is RStudio. So you can just look for RStudio. This was what this program that I was just showing. This is weird. No, I don't want to start. What did I? RStudio download. That's it. Download the IDE. Okay. So if you go there, you can download this. It exists in Windows, Mac, and all flavors of Ubuntu. Of Ubuntu, of Linux. It's a very convenient programming environment. Let me just go back to this. The cool thing is that compared to what I was doing in Jupyter Notebook, you can see that here I can inspect the variables. So you can see I can look at the content of the data. I can run the code as I was running when I had to open little cells. Here I can do it directly. This is the console. I can type our code here while having the code. So this is, of course, probably more convenient in some ways, but the advantage of a notebook is that we're all using the same environment. We're all producing text that looks relatively good. And I think altogether, this is a good thing to learn. But as I pointed out, in R, you would use RStudio. There is an equivalent, a couple of equivalent programming environments for Python, which I'll get into perhaps when I do a very brief intro to Python. But essentially, that's it for this part of the Jupyter introduction.